Not true. We're going to look at one more way, hello, that we're going to apply the derivative.
We're back.
And that's actually going backwards to when we were first evaluating limits. Back in the day of limits, what were some of the things we would do to evaluate a limit? What were some, way back in the day, like back in August, I see you, give me a second. What are some ways that we would evaluate limits? Adriana. Okay, so you could plug the x value into the function, and that always works.
No.
No. Christian, how would you know if it doesn't work?
When the top equals the bottom, so 0 over 0, or when you have infinity.
Okay, if you get 0 over 0, or if you get infinity over infinity, we used to call that the indeterminate forms. We liked plugging in, but plugging in doesn't always work. Sometimes you get the indeterminate form. If you get the indeterminate form, either of the two forms, we had some tricks. What were the tricks? What were some of the things that you would do? Eunice? Maybe you could factor and cancel. That was a thing. What else? What else? Marvin?
Divide by the biggest power.
We would sometimes look at like the powers and see like where we had the biggest power. Sometimes that works. What else? What other tricks were out there? They might even be summarized for you at the top of the page for those of you needing a little bit of an assist. It's our first day back. I understand. We've tried factor cancel. We've done some fancy stuff with degrees. Rambir, what else?
You conjugate it, you multiply by the conjugate.
We would multiply by the conjugate. These were all legitimate things that we used to do. I'm so glad you were able to read that off. All right, here's what you get. You have got 8 minutes working with your folks. You also would sometimes build a table of values and use your calculator. You've got 8 minutes to solve as many of these 4 as you can. We are going back to the days where I care greatly about your notation. That means we're writing limit at every single step except the last step. 8 minutes, you can work with whoever you would like. Whoever's birthday is closest to today, you're in charge of the cups. 8 minutes.
Nor me. I think it's me.
It's today.
I have an AP. Everything's in my
It's yours.
You did disrespect the cups.
No, I've been AP for 2 months. I think. No,
It's freaking cups, it doesn't matter. We never use them.
Well, apparently somebody does use them, dude. They broke it. So you're wrong. You're very wrong.
You have a haircut, that's what you need.
I do. I was supposed to be on yesterday. I was too lazy. They're right there.
Bro, I ain't gonna say shit. You worry me. Sipping on nothing. Eddie came.
Oh, the square root of x.
I don't even have.
I don't know how to factor.
Okay, according to Edgar, the answer to the first one is 2/3. Anybody else getting 2/3?
Yes.
Okay. So it looks like we've got a little factoring, we've got some canceling, he's plugging in, he's getting 2/3. Love it, not a problem. Selected to make you feel good about yourself. Keep going.
Oh, that's what I did.
Yes, I get it.
Oh, fuck.
Square root of x plus 4 plus
Is that glib?
Alright. Don't mind me. I'll be
So right here, what is this?
Do the first one.
X plus 4 or just x plus 4?
Yeah,
I
the first
can't.
one.
You're not gonna know. I know the first one is you. That was probably good to do it. Okay.
Jose.
That's why.
Yeah,
Yeah, see?
What?
Mary didn't do it either.
Just you're like literally almost there. Just factor out. Factor out the bottom and factor out the top.
I did already.
So what did you get?
X minus 6 was 1. See that? I'm done.
No,
X
you
minus
can.
2. What's X over X plus 1?
Well, I did all
Okay.
Fine, do it, 'cause it's easy. I didn't just solve it all right.
If you actually did solve all that in your mind, that'd be good.
Yeah, I totally do that. Alright guys, let's do this.
Me decepcionas. Siempre. ¿Qué hiciste? Ni que te importara. Bye, 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 bye.
So is it 0?
I don't know. I'm not quite sure.
All right, according to Kimberly, I think she's right, but I haven't checked this in a while. The answer to number 2 is 1/4. Anybody else getting 1/4? Okay, I'm going to leave that up there. Number 3 is definitely a much trickier one if you don't see it. If you see it, it's a piece of cake.
I don't think you got 1 for me.
Oh, it's like creepy when I leave my fingers up there.
Where did she get x plus 4 minus 1? X plus 4.
Where did she
This
Maybe I should show you
square
that.
roots cancel each other out.
Can you see that?
If she only cancels the x's, that would still be 4 minus 4.
Huh? 2 times. Whatever, man.
Okay.
I hope you
Yeah.
Yeah.
How did you get 1?
It's not 0 at the top. You use a 1.
Oh, because the x's cancel and they leave a 1?
Yeah, you use 1.
All right, friends, let's pull this together. So how many of you guys honestly were able to completely solve 1 and 2? Okay, pretty good amount. Number 3, who sees it? There's a really specific question that I'm asking you here. What's the question? I've not asked this exact one before, but I keep asking you things in this form because there's a very specific form here. You've got a function minus the function being evaluated at a particular value divided by x minus that same value. Like f of x minus f of c over x minus c. And you're taking the limit as x approaches c. What is that really?
The derivative.
That is the derivative. This is f prime of c. The function in particular that you're looking at is cosine of x. So if f of x is equal to the cosine of x, what I'm asking for is what's the derivative of the cosine of x at pi over 3. And the derivative of cosine of x, everybody remembers, is? Negative sine of x. So I need negative sine of pi over 3. Sine of pi over 3 is square root of 3 over 2. Negative of that is going to be the negative square root of 3 over 2. I would put a little star next to that one. That shows up on like every trimester exam. It's shown up in the unit on derivatives. It showed up in that first unit that we ever did. Don't be surprised if it shows up again. Now this last one, I would hope this is like a 30 seconds or less kind of question for you to look at. Limit as x approaches infinity of e to the 2x plus x over x to the 4th minus 3x squared. There's something that I need you to see here. One person sees it. 2 people maybe. 3, maybe 4. The fact that I'm approaching infinity is the clue. There's something that you know when you're approaching infinity. Eunice, what's the thing that you know?
You see which one goes faster?
When you say which one, you mean the numerator or the denominator, right? Which one grows faster? Top of the bottom. The top grows faster. Jose, why does the top grow faster? How do you know the top grows faster? It's because of that exponential. The exponential is the function that grows fastest of all. So if the top is exponential and the bottom is a polynomial, that means the top grows faster. And if I'm taking the limit as x approaches infinity, and the top grows faster, the final answer has to be? Infinity. Has to be infinity. All of that is about to change. The answers are going to stay the same, but I've got a new idea that I just want to play around with for a little bit that I really think you're going to love. And it's called L'Hopital's rule. Although apparently according to the College Board, you can also spell it La Hospital's rule, and that's okay too. I was raised calling it L'Hopital. You are going to be raised calling it L'Hopital. What's it called?
L'Hopital.
Say it like your French. L'Hopital.
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 There you go.
I'm not gonna do it like
So,
you did.
L'Hopital's rule is this. L'Hopital's rule says if you have an indeterminate form. How many are there?
3.
How many indeterminate forms? 2. One of them? 0 over 0, the other one? Infinity over infinity. If you are taking a limit, and your limit looks something like this, the limit as x approaches c of f of x over g of x. If you get 0 over 0 or infinity over infinity, both of these are called the indeterminate forms. What you can do is this. You're going to take the limit as x approaches c of the derivative of the numerator divided by the derivative of the denominator. This is what L'Hopital's rule tells you to do. So let me say that again. If you're taking the limit of a ratio of two functions, and you get infinity over infinity, or 0 over 0, L'Hopital's rule says, instead of doing that, take the derivative of the numerator, take the derivative of the denominator, and take that new limit. Right now, that probably feels like I have no idea why this works. I know why it works. I'm not going to worry about the proof. I want you to believe me that it works. So let's check it out. Let's look at this first problem. This ought to look familiar. Limit as x approaches 2 of x squared minus 2x over x squared minus x minus 2. If I was just going to go old school on this, I'd plug in and I'd get 4 minus 4 over 4 minus 2 and get 0 over 0. Indeterminate form?
Yeah.
Clearly an indeterminate form.
Yeah.
What you guys just did earlier was you did like the whole factor cancel process, and that worked. I want to use L'Hopital. So we're just going to say by L'Hop, just L apostrophe HOP is fine. What we're going to do is you're going to take the derivative of the numerator. So take the derivative of the numerator, 2x minus 2. You're going to take the derivative of the denominator, 2x minus 1. Notice I'm not saying quotient rule here. I'm taking the derivative of the numerator. I'm taking the derivative of the denominator. Now take the limit. If I take the limit as x approaches 2, I've got 4 minus 2 over 4 minus 1, which is 2/3, which is the limit that you already came up with earlier back in the day when you didn't know about L'Hopital's rule. L'Hopital's rule is going to feel like you're sprinkling magic on the limits, and that's okay. It works. Questions so far? So you can use L'Hopital's rule all the time? Only when you are initially getting an indeterminate form, 0 over 0 or infinity over infinity. If you get anything else, that's your answer. So let's look at the second one. Limit as x approaches 0, square root of x plus 4 minus 2 over x. You guys just did this. You know that the answer, what is it, 1/4?
1/4.
1/4. And you got that through, I know it was a little weird, multiplying by the conjugate.
Yes.
Check out what happens with L'Hopital's rule. First of all, convince somebody near you that you can use L'Hopital's rule here.
So it's 1 over x plus 4 minus 2.
Are we getting it? Yeah, we're just getting 0 over 0. Good. That's the green line to move forward. So by L'Hopital, if I'm going to take the derivative of the square root of x plus 4, I need the chain rule, so it's the limit as x approaches 0, 1 over 2 square roots of x plus 4, minus 0. The derivative of x in the bottom, 1. Take that limit as x approaches 0. You've got 1 over 2 square roots of 4, minus 0 over 1, which is 1/4. Exact same answer that you came up with before. And you didn't have to worry about multiplying by the conjugate. L'Hopital's rule is awesome as long as you have an indeterminate form. Try the third one.
So do we need to memorize that? What the sign of pi over 3 is?
Yeah, you did that last year.
This is a number. This is a number. So it will be 0.
Is everybody convinced the third one you get to use L'Hopital's rule? Okay. So just make sure you write a little note. So by L'Hopital, now I'm going to take that limit as x approaches pi over 3, derivative of cosine of x, negative sine of x, minus derivative of cosine pi over 3.
That's a number.
Cosine of pi over 3 is a number, so the derivative of cosine of pi over 3 has to be 0. The derivative of x, 1, minus derivative of pi over 3, still 0. Now try plugging in and you're going to get negative sine pi over 3 divided by 1. So negative square root of 3 over 2. 3 in a row. 3 in a row, where the old way matches up with the new way. The new way is awesome. Let's try this last one together. If I take the limit as x approaches infinity, I get e to the infinity, which is infinity, plus infinity. Infinity to the 4th minus 3 times infinity squared is going to be infinity. Indeterminate form? Absolutely. So try L'Hopital. L'Hopital's rule says take the limit as x approaches infinity. The derivative of the numerator, the derivative of e to the 2x, it's been a while, but that's a chain rule, e to the 2x times 2, plus 1. In the denominator, derivative of x to the 4th, 4x cubed, minus the derivative of 3x squared, 6x. Take the limit as x approaches infinity. E to the infinity is infinity times 2. Infinity plus 1. Infinity. 4 times infinity cubed. Infinity. Minus 6 times infinity. This is a bigger infinity because of the cube. Infinity over infinity.
1.
Which is not infinity. It's not 1. It's an indeterminate form. Thank you so much for saying that. So guess what? What was that?
Take it again. Take it again.
Can you use L'Hopital's rule again?
Yeah, yes.
In order to use L'Hopital's rule, the only thing you need to know is that you have an indeterminate form, which we've got an indeterminate form. So do it again. So by L'Hopital, take that limit as x approaches infinity. You're taking the derivative of this new numerator and the derivative of the new denominator. The derivative of the new numerator is e to the 2x times 2 times 2. Derivative there is 0. Derivative in the denominator is 12x squared minus 6. Take the limit as x approaches infinity. E to the infinity is infinity times 2 times 2. Infinity. 12 times infinity squared. Infinity minus 6. Infinity. Another indeterminate form.
Keep going to the bottom.
You are going to keep on going. So keep on going. I know, it makes me want to slap my table and say, oh, thank God I'm in calculus. So by L'Hopital again, limit as x approaches infinity. Derivative of e to the 2x, yep, still e to the 2x, times 2 again, times 2 again, over 24x. Take that limit as x approaches infinity, yep. Infinity over infinity again.
Ya no puedo.
I don't even know what that means. I hope it means indeterminate form. I'll have to play back the film later. Take the derivative again. So you've got the limit as x approaches infinity, e to the 2x times 2 times 2 times 2 times 2 over 24. Take the limit as x approaches infinity. You've got infinity over 24.
That's infinity.
Which is not an indeterminate form. Mariah, you still with me? Hi, I'm the good looking guy over here. Infinity is the final answer. Infinity over infinity can't be a final answer. 0 over 0 can't be a final answer. But infinity is a great answer. As far as I understand, when it comes to the world of calculus AB, this is as much as you need to know about L'Hopital's rule. So that's why I'm only going to spend one day on it. That this was all that there is in the world of L'Hopital's rule for us in the world of calculus AB. Okay? So here's what I want you to do. I want to give you guys some practice. I want you to flip over to page 4. Tonight's homework is pages 4 through 6. There's 12 multiple choice questions. This should take no more than 25 minutes. You are going to be tempted to use L'Hopital's rule again and again and again. I will tell you some of these problems you cannot use L'Hopital's rule. Jose, how do you make the decision about using L'Hopital or not using L'Hopital?
If it's 0 over 0 or infinity over infinity, I'll call it indeterminate form.
There you go. So if you get 0 over 0 or infinity over infinity in your first move, that's when you use L'Hopital's rule. If you don't get one of those, don't use L'Hopital. I want to give everybody the next 10 minutes to play around with these. The goal should be to at least get 5 of these done. Person who's in charge of the cups, you're still in charge of the cups. At 2 o'clock, we're going to shake up the groups a little bit and go for some extra innings for those of you that are looking for more of a challenge in the world of L'Hopital.
X
Over 3, 6. I'm actually guessing. I'm making it.
What in it?
You did a great job.
Yeah. Number 1?
I got B. I'm pretty sure crap is not 1. Oh, you're right. Yeah. Power 4 C.
You're right.
Because they're the same 3, so you just ignore everything. 1 over 4.
Oh my
I
gosh.
forgot about that too. It's okay.
I forgot about that.
I don't know why I put prime, guys.
Prime.
Yeah.
What would you tell us?
Oh, is that what the point of that is?
Yeah, it's the point since you don't see girls. Now I know.
What is the actual
Nobody really cares.
I know, yeah.
I don't know. That's a good question. What?
As long as you're passing.
The derivative.
69. Dang. I would have been sad.
Aww.
Oh, crap, that camera.
The camera's floating. Queen Elizabeth.
Somebody will be hired.
Somebody whose middle name is Elizabeth.
PT, related. I do not know. It was probably something that you were not here for.
I got a grade.
Obviously, you did the makeup work, did you not?
Okay. Yep.
So I want to show them this.
Oh, that's you,
When
and
they grow at the same rate, things work out.
Are you?
When they grow
Yes.
at the same rate.
I wouldn't want her to except the mosquito. Definitely though.
Okay, so I'm not saying that
Image
just
amendment?
when the degrees are the same.
What quiz is this?
Optimization.
What's the one on?
These two papers?
Another way.
This is the first one.
Is that the one I was listening to? No.
Mr.
Yes, ma'am.
What's this?
Can we talk about that later?
Yeah.
No, I did.
Okay, let's focus on L'Hopital. Okay, so you got 1-4.
I got B.
Because of that, right?
Okay, so you first took the limit as x approaches infinity, and you got infinity over infinity.
Yes.
Okay, so you use L'Hopital's rule. So you took the derivative, you took the derivative. You're seeing x squared, they're growing at the same rate. So the limit, you just look at the coefficients and you get 3 over 12, which is 4. Great. What if you had done that in the beginning?
Yeah.
What do you mean? Done what?
It's not equal
Looked
to
at the.
0.
Oh wow. Yeah.
Wouldn't you still get 1/4?
Yes.
Okay. So this is another tool in the toolbox for you to use. But you have to first convince me that you have an indeterminate form. You're not just going to go and take the derivative this new way just because. It's going to have to be because you're getting 0 over 0 or infinity.
This is fun.
I will skip number 3. Who knows how to do the Actually, who's done 2?
Good. So did you take a whole bunch of derivatives?
I got B for
Okay,
2.
good. That's what I got.
Or you could have looked instead of the derivatives are the same here, so let me look at the coefficients.
So I tried doing number 3, and I think I got it.
Did you have done that?
I
I
tried.
forgot how to do the squared thing.
I tried to read it. And I
They're
couldn't
both
do
so
it.
we're going to 2, so you would say, oh, the limit's going to be 3 over 12. 3 over 12.
You got.
There's like a reason, there's like a way to do that.
No, don't you just take it out or something?
The whole equation.
Like 2 sine and like cos.
Okay.
I think that's what he said.
It's something like that. It's 2 sine times cosine.
What?
Yeah. you're right. I just think of it as sine times sine. So it's a product. That's how I think about it.
I just think.
We think of it as exponential. No.
I just think
Not
about.
exponential. No, when we do it this way. In a chain rule.
Okay, I just take the 2 out. I don't know. I know these things. Just take the 2 out. Okay. And be honest.
What? So then it's 4 sine?
Sine of 0 is 1, right? No, it's 0. So the bottom
Wait,
is
I'm
0.
confused.
It's 0 over 0, yeah. Okay.
Anthony over here has 2x not 2a.
0
I know what.
sine of 8.
I'm confused on what you're saying.
2 times.
I completely forgot the camera was here. Hi, people. I'm currently suffering. Calculitis. Wait, so how would it turn out to be? Would it be 4 sine squared? I got A.
I'm finished. I got sine of theta over 2 times cos of theta. And cos of 0 is 1. And sine of 0 is 0.
Chain rule would be mama, baby.
Yeah. Just I don't think of it that way.
Wait, chain
Chain
rule.
rule.
Because we solved it
Sine
before.
squared is chain rule, yeah. I mean, you can think of it as chain rule.
Just find the derivatives.
That's why sine at the top, right?
Positives.
Yeah, I know. The bottom, that's the only thing I was.
It's 2 times 2 times the derivative of sine.
Cosine. Is this 4 cosine?
A is a constant, and it's a constant.
That's more like it. Oh, you
Who says that? Alright. How can people not say that? That sounds so So what do people say now? Loser? No, sucker's so much better than me.
Did you get A for 4?
Right, but when you put A to the
And for 5 it doesn't matter, right? It's the same thing. It's A.
5?
Because regardless, those would be 0. The only thing that changed was the bottom.
5
No.
plus 5 is 10.
It's 10, 0,
0 over 10. 7.
X, it would be A square root.
On an autopilot.
I don't know.
We don't
I
have
only
autopilot.
thought of like
Yes, sir.
taking the derivative. That's what he said.
You say, what did you get
Can't
for
be a
the
sucker,
two?
man.
Why? You're supposed to have 5 then. All you need to do is take the derivatives. You're not in a break. Okay, it's time to try again.
Very
You need to try again. Just try.
All right, if I could stop all the good multi-call action for just a little bit. Okay, so challenge by choice here. The questions that you're doing right now are on par with the kinds of questions I'm going to ask you on the test on Friday. They are consistent with the level that you're going to see on the AP exam. And from what I've seen, most of you guys are doing very well and you're off to a great start. For those of you that are hungry for a little bit more, you want to get a taste of what we did in Calculus BC with L'Hopital's rule. I want to spend the next 10 minutes kind of giving you a taste. You are not going to have a harder homework assignment or a harder test or anything else like that. I just want to give you a taste of what more else is there in the world of L'Hopital. Anybody interested in the taste of what else is out there? I see Rambir, I see Daisy, I see Adriana, I see Kimberly, yep, I see Giselle too, and I see Nora. Excellent. So I'm going to ask that we shuffle, and Rambir and Jonathan and Marvin, I saw you guys as well. So those of you that just volunteered or voluntold, you're going to move to the front. Everybody else is going to go to the back. Folks that are in the back, you are going to continue working on the homework assignment that's due tomorrow. Folks that are in the front, either by your choice or mine. And let's turn the camera. Thank you very much. Giselle, can you make sure that we're in focus over here? All right, Eunice, are you going to join us or are you going to stay back there with the men? Okay, not a problem. Excellent. Marty, you're stepping up for the challenge? Excellent. Good choice. All right. So, here's the thing. For folks that are in the front, there are two indeterminate forms that you know. Folks in the back, keep working on the homework. Keep working on the homework. There are two indeterminate forms that you know, 0 over 0 and infinity over infinity. My question for y'all is, why are they indeterminate forms? They're unsolvable. That's one way to say that. What else? It's not a number. Okay. Some folks would explain indeterminate forms this way, and I think it's a good explanation. 0 over 0, some people could argue and say that that has to be 1. The people that see this as 1, what are they thinking? What's the rule that they know?
Same number on top and bottom.
If you are dividing a number by itself, don't you always get 1?
Yeah.
Okay, but some other folks might say, oh, but I think it's 0. Anybody know a rule that they're thinking about here? What number rule do you know for division? Why would they be thinking 0? There's something you know about division.
When zero's in the numerator.
When 0's in the numerator, 0 divided by a number is okay, right? 0 divided by a number is 0. But other folks would say, oh, this is undefined. What are those folks thinking? If the denominator is equal to 0, it's a no-no, right? Maybe you learned the okay, no-no idea. So maybe it's 1, maybe it's 0, maybe it's undefined. The reality is we don't know. It changes. It changes all the time. Infinity over infinity has similar issues, similar problems. There are several other indeterminate forms. Here's another one. Infinity times 0 is an indeterminate form. Why? Anybody know a rule about multiplying by 0? You get 0. Anybody know a rule about multiplying by infinity? Right, infinity times the smallest number is still infinity. Any number times 0 is still 0. When you multiply infinity and 0, indeterminate form. Here's another one. Infinity minus infinity. What might somebody think about? Think the answer. A good argument would be 0, right? A number minus itself is 0. Somebody else could argue infinity. Infinity minus a number is still infinity. You might also argue negative infinity, right? These are all valid thoughts to have, but infinity minus infinity is an indeterminate form. Here are some other ones. 1 to the power of infinity. 0 to the power of infinity. Infinity to the power of 0. There's another one that completely escapes me right now. 1 to the infinity.
Wait, you already put that one.
I already have that one, thanks. There's another one that'll just remain a mystery until I can check my notes. All 5 of those are indeterminate forms. Right here.
How is it indeterminate if, like, we know for a fact that some of these are rules that can equal a number?
But they're actually not.
But anything, like, for example, anything to the 0 power, we know equals.
Okay, so a rule is anything to the power of 0 is 1, right? But another rule is infinity raised to a power is infinity. Right, so you've got this conflict of rules coming together. And so mathematically we have a problem. L'Hopital's rule is going to solve all our indeterminate form woes. All of them. But we're going to have to be tricky. So let's look at this first one. Convince somebody near you that that actually is an indeterminate form. Is that an indeterminate form? If it is, which one? Which indeterminate form do we see? Jasmine, stay with me. Okay. Which indeterminate form? The third one is if you're raising 1 to the power of 50. I've got e to the negative x, and x is approaching infinity. As x approaches infinity, e to the negative x, what happens with that graph? For those of you that have just tried plugging in infinity, you're going to have something on your paper that looks like e to the negative infinity times the square root of infinity. What happens here? E to the negative infinity. It's not negative infinity.
0. 0.
This is 0. If you think about the graph of e to the negative x, can you guys draw e to the negative x in the air? It's been a while. E to the negative x, e to the negative x. Does it increase or does it decrease? E to the negative x decreases. So as x approaches infinity, e to the negative infinity has to get close to 0. Square root of infinity is infinity. Indeterminate form. Okay? Because it's the indeterminate form, I want to use L'Hopital. But L'Hopital's rule is only ever going to work if you have a function divided by another function. That's the only way L'Hopital's rule works. So you've got to get clever and rewrite the problem using legal algebra. Anybody see legal algebra that you can do? Nora, what do you see?
The square root of x.
So we're going to rewrite this. Limit as x approaches infinity. I heard square root of x.
Wouldn't square root of x be x to the 1/2?
Square root of x is x to the half. L'Hopital's rule only works if you have a function divided by a function.
Will we do the derivative already?
L'Hopital's rule only works if you have a function divided by a function. You see it?
Since the exponent is negative, to make it positive, wouldn't you bring it down to down?
Is that legal?
Yeah.
Is it legal to move it downstairs? Now, Nora, the stuff you were saying is right. Square root of x is x to the half, and all that's good. But the question is, can I use L'Hopital's rule?
Yes.
Convince me that I can use L'Hopital's rule.
Because it'll still, once you plug it in there, it'll still give you the indeterminate form.
Okay, but now I'm getting the indeterminate form infinity over infinity. So now this is just like a homework question, and you're going to say, all right, let me try L'Hopital. L'Hopital's rule says take the limit as x approaches infinity. I need the new numerator. Derivative of the square root of x.
1 over 2.
1 over 2 square roots of x. New denominator. Not e to the x times x, just e to the x. Take the limit as x approaches infinity. X approaches infinity, you've got 1 over 2 square roots of infinity. 0 in the denominator, I've got infinity. Is that one of the indeterminate forms?
Nope.
No. 0 over 0 is an indeterminate form. Infinity over infinity is an indeterminate form. This isn't an indeterminate form. 0 divided by a number. 0. A number divided by infinity? 0. So your final answer here is just going to be 0. So tonight's homework for folks in the back.